In section 2.3.2, we're going to continue to talk about this idea of standard deviation, which was one of our measures of spread that we discussed in the last section. What we want to try to understand is ultimately how we can use this standard deviation to better understand how the data within a data set is actually distributed or dispersed. Now, really quickly up here at the top, I'm going to go ahead and pull back on an idea that we talked about in the last section. Remember that when we dealt with the idea of the IQR, we thought about dividing our data set up into these kind of different portions. We had a min, we had a max, we had our median, which was the halfway point, and then we could measure halfway points of kind of the upper and the lower half. Now, we called these values Q1, Q2, and Q3. And remember that the IQR was simply going to be the distance that existed between Q1 and Q3. That was the IQR. But the cool thing about the IQR is that because of the way that these quartiles break up a data set, we knew that that quartile, or these quartiles broke up our data set into kind of 25% chunks. And so the IQR covered the middle 50% of the data. So when we had that IQR number in the last section, we were able to say, the IQR, that is talking about the spread over a middle 50% of the data. Now, when we talked about the idea of the standard deviation in the last section, we did something very similar, kind of like what's down here below. Just focus for the moment on this little number line that I have down here in this picture. What we did in terms of creating a similar sort of interval with our standard deviation is we said, let's start at our average, and we went up by a standard deviation, and we went down by a standard deviation. And we were able to create, again, a little interval that had a starting point and a stopping point, kind of like how the IQR has a starting point, or the interval the IQR covers has a starting point at Q1 and stops at Q3. Again, the advantage of IQR is that we knew that this was talking about the spread over a middle 50% of the data. But when we talked about standard deviation in the last section, we just said it was pretty typical to find a data value inside of these bounds or in this interval. But we didn't really state like some sort of a percentage associated with that. Right? We didn't have anything like the idea that IQR helps talk about the middle 50% of the data. So that's what we'd like to try to develop in this section. And we do this by using what we call the empirical rule, or what is sometimes referred to as the 68, 95, 99.7 rule. So let's take a look at what this rule says here really quickly, just to get a sense of what this, or how we will use this in the problems to come. So here's what it says, and this is really important. For data with a symmetric or bell-shaped distribution, if you have that shaped distribution, then the standard deviation has the following characteristics. Notice what we have down here is that, again, I have my average in the center, and I can see that if I move up one standard deviation and down one standard deviation, I create this interval over here. I can see that I have these percentage markers in here. What this means is that 34% of the data set should be somewhere within this first standard deviation in the positive direction. And another 34% of the data will be within a standard deviation below my original x bar value. So in total, I can make the statement that about 68% of the data of my data set lie within one standard deviation of the mean. Notice that this 68% is similar or related to kind of this 50% that we had up here for the IQR. They're obviously not the same number, but if IQR covers the middle 50% of the data, we can see that my standard deviation is going to say that the interval that I create from that is going to contain roughly about 68% of the data. Okay, so this is great. Now again, this doesn't work all the time, only in a nice bell-shaped distribution. The cool thing, though, is that we can go further from this. Notice if I was to take an extra standard deviation jump out to the side, if I go up on the right side, I add another 13.5%. If I go down again on the left side, I'm going to add another 13.5% as well. And so if I move 2 standard deviations away from the mean in each direction, and I kind of form this big interval here, then about 95% of the data falls within that range. You'll notice that if I move out one additional standard deviation in both directions, I almost grab all the data. In fact, I get up to about 99.7% of all of the data. Past 3 standard deviations, hardly any of the data occurs over there at all. Notice that's a number of 0.15%. That's less than a single percent. So what this empirical rule is really telling us is kind of every time I make a jump with a standard deviation, what percent of the data is going to be covered. Just like here, every time I made a jump of a quartile, I know I covered 25% every time. But jumping with standard deviations in a bell-shaped distribution produces these numbers. And we're going to see how we can use these numbers to answer some questions in the videos to come.